Now, before you go and throw away all of those disposable wooden chopsticks you have piled up from your takeout meals, consider this. Berkeley GSC professor Dor Abrahamson once took 4 chopsticks and attached them together with rubber bands to make a square. Then he asked a bunch of questions. When you're holding a square and you rotate your hands, what does that feel like? What changes? What stays the same? What shape do you get? And what if you are visually impaired? What does it mean to learn a geometric shape that you cannot see? About a year and a few more questions later, Professor Abrahamson and a team of researchers from 2 other universities had some of those answers. And that has earned them the Best Paper Award at one of the top assistive technology conferences in the country. What they've created is called the Quad. It's a handheld geometric manipulative designed for sighted and sight-impaired students to learn math together. It's the ultimate in inclusive learning. The Quad allows students to learn geometry no matter if they have 20/20 vision, 20/50, or 2200. What started out as chopsticks and rubber bands is now a 3D printed versatile quadrilateral with sides that can shift and extend. What's better, the Quad can be plugged into a computer that shows a digital copy of its movements and reads out the measurements. It all started because of Professor Abrahamson's curiosity. He's continually seeking ways to improve mathematics education, and he says if we want students to think in new ways, then we need to create the conditions for them to engage with the world in new ways. That means creating platforms so that students who we think of as typical learners and students we might consider atypical learners can collaborate on activities in an inclusive classroom. Professor Abrahamson designs technologies for students to learn how to move in new ways so that they can think in new ways and understand new concepts. In order to build and test these technologies, he collaborates with equally curious researchers from across the world and from a network of disciplines. In the case of the Quad, his Embodied Design Research Laboratory collaborated with the Chrome Lab at St. Louis University and with PhET Interactive Simulations at the University of Colorado, Boulder. Professor Abrahamson's research lab is rooted in exploring the learning sciences, developing theories of how we learn, and inventing new frameworks for designing educational technologies. The engineers at the Chrome Lab built the Quad, and the researchers at PhET created the software that translates the Quad's movements into measurements that are then read out on the computer. The resulting paper from this research collaboration is titled A Tangible Manipulative for Inclusive Quadrilateral Learning, and it has earned the Dr. Arthur I. Karshmer Award for Assistive Technology Research from the California State University Northridge Assistive Technology Conference, known as the CSUN AT Conference. For more about the Quad's origin story and Professor Abrahamson's aha moment regarding his own vision-centric way of thinking, be sure to visit gse.berkeley.edu/quad-origin.